Hi everyone. Today's lesson is on properties of rectangles. So we've already learned about parallelograms, and a rectangle is going to be a special type of parallelogram where we have four right angles. So each one of these angles is going to be a right angle, which means we have four corners there, four right angles. Now, because a rectangle is a parallelogram, it's a special type of parallelogram, all those properties that we learned about for a parallelogram are also going to be true for rectangles. So for a rectangle, we know that the opposite sides are parallel and congruent. We know the opposite angles are congruent. We know the consecutive angles are supplementary. And here it's a little bit easier to see these properties because every angle is going to be 90 degrees. And the diagonals bisect each other. Okay, so those five properties about a parallelogram are also going to be true for a rectangle, in addition to the four right angles. That was our definition of a rectangle. And then the other property that's going to be new about a rectangle is that the diagonals are congruent. So this diagonal here is going to be congruent to this diagonal here, okay? Now, we knew that the diagonals bisect each other, so this piece was congruent to this piece, and this piece was congruent to this piece, but if the diagonals are congruent, now each of these four pieces is going to be congruent. So not only do we know that the diagonals are congruent, but each of those four pieces are going to be congruent to each other as well. All right, so let's practice applying those properties. Our first set of problems says for each of the problems below, determine which property of rectangles is depicted and then solve for the missing angle. So if I look at number one, I see this 8x minus 4 is referencing this angle here. So I'm going to be using the property that a rectangle has four right angles, which means I can set 8x minus 14 equal to 90. I'm going to add 14 to both sides. So 8x equals 104, and divide by 8, and x equals 13. Now, for number two, it's giving me information about AC, which is one of my diagonals, and BD, which is my other diagonal. So I'm probably using that property, diagonals are congruent. And I'm just going to abbreviate that there. So I can set 6x plus 5 equal to 17. Subtract 5 from both sides, and 6x equals 12. So x equals 2. And for number three, AC is my whole diagonal here, that's 56. All right, so this whole thing here is 56. And then EB, this piece here, is 13x minus 11. Now this one's a little tricky, but I know that because this is a parallelogram, if EB is 13x minus 11, then ED is also 13x minus 11. And this whole segment BD is going to be congruent to AC, which is 56. So I can set two of those 13x minus 11s equal to 56. I could have also written 13x minus 11 plus 13x minus 11, but I'm going to write it this way so it's a little bit quicker to solve. I'm going to distribute that 2. So I have 26x minus 22 equals 56. Add 22 to both sides, and I get 78. And then divide both sides by 26, and x equals 3. Okay, and again, the properties that I was using here is that the diagonals are congruent. Okay, now number 4 is a little tricky. So number 4 is giving me this length of BD. It's giving me the length of CD and asking me to solve for x. Now, pretty important here, right? So I'm highlighting this triangle, and because this is a rectangle, I know this has to be a right triangle. So I'm going to use the Pythagorean theorem. All right, so we have 11 squared, or I'm sorry, x squared plus 11 squared equals 14 squared. Let's simplify this. So we're going to have 121 equals 196. X squared equals 75. And then I'm going to take the square root of both sides. So x equals, now I can either reduce this. If you are simplifying radicals, I can simplify this to the square root of 25 times the square root of 3. So x equals 5 times the square root of 3. Or if your teacher lets you plug it into a calculator and get a decimal, x would equal 8.7. All right, so either one of those answers, I'm going to put both of them there. So 5 root 3 or 8.7. And the property I used was, I used the Pythagorean theorem, but I'm using that because I know that's a right angle, because my rectangles have 4 right angles. Okay, let's look at our next set of problems. So here, not only are we going to have to solve for a variable, but then we're going to have to substitute that back into our diagram to solve for some of these measures. So for number 5, we want to find the measure of angle RSU. That's this angle here that I'm going to highlight in yellow in this rectangle. So I see that these two angles, right, are going to have to equal 90 degrees. They're going to have to be supplementary because this is a rectangle and every one of these angles is going to be 90 degrees. So I can take my 9x minus 7 plus 7x plus 1 and set that equal to 90. So when I combine my like terms, I'm going to have 16x minus 6 equals 90. Add 6 to both sides. And x equals 6. Now I'm not done. All right, I'm going to take that value x equals 6 and substitute that back into the measure of angle RUS. So 9 times 6 minus 7 is going to be 54 minus 7, or 47 degrees. Okay. Number 6, I want to find the measure of segment JL in this rectangle here. It gives me JL. It gives me the length of diagonal MK. So I can set these equal to each other because they are congruents. So I'm going to have, I subtract 3x from both sides. 2x minus 18 equals 6. Add 18 to both sides. So 2x equals 24. And when I divide both sides by 2, x equals 12. Right, again, I want to take that value x equals 12 and substitute it into JL. So 5 times 12 minus 18. I have 60 minus 18, which is 42. So the length of JL is 42. Now, number 7, I talked about a little bit before. So it gives us the measure of segment HI and then segment IG. Now, if we kind of scroll back up here, we talked about how each of these diagonals are congruent. And if each diagonal bisects each other, then each of these pieces is going to be congruent. That is always going to be true about every rectangle. So if I go down to number 7, this segment HI is also going to be congruent to segment IG. So I can set 2x minus 5 equal to x plus 8. I'm going to subtract x from both sides, so I'm left with x minus 5 equals 8. Add 5 to both sides, and x equals 13. And I can take that value, substitute it into IG, so 13 plus 8 equals 21. Now, number 8 is asking me to find the measure of angle ZXY in this rectangle. Now here, even though I'm looking at angles, I'm actually using those properties of diagonals again. So again, because we know a rectangle is a parallelogram, the diagonals are going to bisect each other. Okay? But because the diagonals are congruents, all right, each of these pieces is going to be congruent. So if I look at these pieces of my diagonal, all right, I can see that I have a triangle with two sides that are congruent to each other. That's going to be our isosceles triangle here. And if we remember from the isosceles base theorem, it tells us that if we have a triangle that has two congruent sides, we're going to have two congruent base angles. Right? Those angles across from your congruent sides are also congruent. So to solve for x here, I can set 9x minus 5 equal to 6x plus 22. To solve for x, I'm going to subtract 6x from both sides. So I have 3x minus 5 equals 22. Add 5 to both sides and divide both sides by 3 to get x equals 9. And I can take that value for x and I'm going to substitute that back in to this angle ZXY, which was 9x minus 5. So 9 times 9 minus 5 is 81 minus 5, or 76 degrees. Okay. And finally, for number 9, it says solve each of the missing angles or segments below. So we're going to use the same strategy. Let's try to find the segments first. So if I want to find LM, I know that PN is 8. LM is my opposite side, so they have to be congruent. If I want to find OM, OM is a piece of a diagonal, and each of those pieces is going to be the same. So OM would be 5 because LO was also 5. Next, I want to find MP, so I want to find this whole segment here. So if OM is 5, OP is 5, and then that whole diagonal is going to be 5 plus 5, or 10. And then finally, I want to find MN, okay? What I can do is I can take this side on top, this side on the bottom, and I know my diagonal is going to be 10, and use the Pythagorean theorem, okay? So I'm going to do this up here. I have x squared plus 8 squared equals 10 squared. So x squared plus 64 equals 100. All right, and x squared is going to equal 36. So x is 6. That's also one of your Pythagorean triples, so it definitely helps if you know those Pythagorean triples. You would have gotten that a lot quicker without having to do that work. Okay, now I'm going to erase all the stuff with my sides. All right, so I can kind of start fresh with my angles here. Okay, the first angle I want to find is angle LPM. So here I'm looking at this angle here. Because this is a rectangle, I know each of my angles is 90 degrees. So if I'm looking for this angle here, I'm just calling that x. I can do 90 minus 27, and that's going to be 63 degrees. All right, so this angle here is 63. Next, I'm looking for angle PNL. Okay, so this guy right here. Now, if we remember, we talked about isosceles triangles in question number 8. We had an isosceles triangle here. I also have an isosceles triangle here. Okay, you're actually going to have 4 isosceles triangles in a rectangle. So the same thing is going to happen here. I know these pieces are all congruent. So in this bottom triangle, I have my 2 congruent sides of my isosceles triangle, and those opposite, the opposite angles from my congruent sides are going to be congruent. So this angle is 27. This guy right here is also going to be 27, which is P and L, which I'm trying to find. Next, I'm looking for PON. So I know this angle was 27. In that isosceles triangle, I have 180 degrees. So I know 2 out of my 3 angles. So 180 minus 27 minus 27 is going to be 126 degrees. So I'm going to put that right there, 126. The next angle I'm looking for is MON. All right, so if I'm looking for this angle here, I see that I have a linear pair, right? These angles form a straight line. So I can take 180 degrees minus 126, and I'm going to get 54 degrees. And finally, angle LMP. All right, so I'm going to do this in blue here. I'm going to call that Y. This angle that I'm trying to find here has to be 27 degrees. All right, remember this is a rectangle and the opposite sides are parallel. So if I look, let me make this a little bit thicker and do this in a different color. I have my parallel lines and a transversal. So just like when I was doing parallelograms, I can also use alternate interior angles. So angle LMP is going to be an alternate interior angle to MPN, which we know is 27 degrees. Okay. And finally, number 10, we're looking at the rectangle shown below. We want to circle all of the statements that we know are true. So let's take a look. It says segment AB is congruent to segment BC. That's not going to be true. Those sides are next to each other. They're not opposite, so we don't know if they're congruent. Angle DAB is going to be congruent to DCB. Well, those are opposite angles, and they're also both going to be 90 degrees. So I know each of these guys here is 90 degrees. So that one's going to be true. AE is a piece of my diagonal is congruent to EB. That's another piece. So remember, each of those 4 segments are congruent. So AE is congruent to EB. Angle BAC is congruent to DBA. So let's look at that. BAC, so that's going to be this angle here. BAC is congruent to DBA. Okay, that one looks like it's going to be true. So remember, we have our isosceles triangle. All right, so here's one of our isosceles triangles. Those base angles are going to be congruent, so we can say BAC is congruent to DBA. BE is congruent to ED. All those pieces are congruent, so that one's going to be true. BAC is congruent to BCA. All right, so here we're looking at that angle BAC and BCA, this one here. Those are not going to be congruent. Let's erase these and kind of start fresh here. Next, we have ADB and BDC. All right, so that's this angle X and Y here. I know they're going to be complementary, but they're not going to necessarily be congruent. Segment AC is congruent to BD. Those are both my diagonals, so I know those have to be true. And then angle ADB is congruent to DBC. So ADB and DBC, those are going to be congruent. Again, those are my alternate interior angles. So I have my parallel sides, my transversal. All right, so those are alternate interior angles, which means they must be congruent. And those are all the statements that we know are true. That's our lesson on properties of rectangles. If you have any questions, you can put them in the comments below. Thanks so much for watching.